Good morning, one and all. My name is Endur Gaurav from EC Department, Vignan Snerla. Today we will discuss the problems on Laplace transforms. That is the main introduction to the Laplace transforms. We have seen it, and the relation between the Fourier transforms and Laplace transform, we have seen it. Now coming to the while considering the Laplace transform and its ROCs, we need to see the particular problems. Like the first one, as if we have calculated that the Fourier Laplace transform of x of t as e power minus at u of t, whose corresponding Laplace transform as x of s, which is equal to 1 by s plus a. But the region of convergence as RE of s will be greater than minus a. Similarly, if we take the another signal, x of t is equal to minus e power minus at u of minus t, then its Laplace transform as x of s, which is 1 by s plus a, and the RE of s will be less than minus a. RE of s will be less than minus a. Like this, we'll start by using these two Laplace transforms. We can have a number of variety of problems that will be illustrated. The first problem is, for example, if the x of t is equal to e power minus 2t u of t plus e power minus 3t u of t. This is a right-sided signal. It's a right-sided signal. Why it is called as a right-sided signal means, for both of them we'll have the u of t only. That is, in the positive section only we'll have the signal. That is, x of t is equal to e power minus 2t u of t plus e power minus 3t u of t. Therefore, in this case, when we want to find out the Laplace transform x of s, therefore e power minus 2t u of t means it is in this particular form. Therefore, its Laplace transform is 1 by s plus a, and the region of convergence is RE of s will be greater than minus a. That's why Laplace transform is 1 by s plus 2. Next, plus here also the same 1 by s plus 3, but RE of s will be greater than minus 2, and here RE of s will be greater than minus 3. Therefore, our region of convergence will be like this. For taking the sigma and j omega with now the first pole is at s is equal to minus 2 and another pole is at minus 3. This has minus 2, this has minus 3. For the first one, that is RE of s will be greater than minus 2. If we take a line on the sigma is equal to minus 2, towards the right side is your ROC. Next, for minus 3 again, it is again the right side towards the minus 3. Therefore, the intersection part is this one, where does not have this part as an intersection. This is the only part that indicates our RE of s will be greater than minus 2. Greater than minus 2. That is, it is nothing but this is the one pole is at minus 2, another pole is at minus 3. For a right-sided signal, the ROC is right of the rightmost pole. Right of the means this is the right of the rightmost pole. The two poles are at minus 3 and minus 2. In these two poles, the right side is 1, minus 2. Therefore, towards that right, we'll have the ROC. ROC is right of the rightmost pole. Rightmost pole. Right of the rightmost pole. It is being the right of the rightmost pole. Similarly, if you take the x of t signal like this, This is the illustration that the x of t is a right-sided signal. Therefore, ROC is right of the rightmost pole. Similarly, when the x of t is equal to e power minus 2t minus u of minus t plus e power minus 3t u of minus t. Remember this, because of this u of minus t, the signal here, it is a left-sided signal. Therefore, corresponding x of s will be given as, it is the 1 by s plus 2 only, because here it will satisfy this condition, therefore 1 by s plus 2, but here it is the presence of u of minus t, but minus is not there, therefore keep the minus here, and 1 by s plus 3. This is for, here will not have the minus, therefore for this one the region of convergence is RE of s will be less than minus 2. For this one RE of s will be less than minus 3. Therefore when we draw this particular one, minus 2, minus 3, first one is below this particular minus 1, minus 2, like this. Again minus 3, below this minus 3 will have the another one. Therefore the intersection indicates that RE of s will be less than minus 3. RE of s will be less than minus 3. That's RE of s will be less than minus 3 is your ROC. RE of s will be less than minus 3 is your ROC. That is for a left-sided signal. The poles are at here at minus 2 and minus 3. Towards the left of the leftmost pole. Leftmost pole is minus 3. Towards that left we'll have the ROC. That is for a left-sided signal, the ROC is left of the leftmost pole. Leftmost pole. Of the leftmost pole. That is left of the leftmost pole, here right of the rightmost pole. For a right-sided signal, the ROC will be right of the rightmost pole. For a left-sided signal, ROC is left of the leftmost pole. Okay? Now consider the two-sided signal. Let us consider that x of t is equal to e power minus t u of t plus e power minus 4t u of minus t. This is a two-sided signal. This indicates the right side. This indicates the left side. As the u of t is present, it's a right-sided signal. U of minus t is present, it's a left-sided signal. Therefore, combinedly this one has the two-sided signal. Two-sided signal. For this particular two-sided signal, the Laplace transform as, for this particular one, 1 by s plus 1, with the region of convergence as RE of s, as u of t means greater than minus 1. Here minus sign is not there, therefore keep the minus sign here, and it will be in the form of e power minus 8 u of minus t. That's why its Laplace transform as 1 by s plus 4, and the RE of s will be less than minus 4. We can write like this, but we cannot get the exact Laplace transform with the region of convergence only. Okay? The exact Laplace transform will be determined by the region of convergence. Let the RE of s will be greater than minus 1. If we take at minus 1, it will be greater. It will be greater, first one. Next, at minus 4, the RE of s will be less than. Therefore, there is no common region between them. Okay? This side, one region, this side, another region. Therefore, the no common region between the ROCs. Hence the Laplace transform does not exist. X of s does not exist. Whenever the common region is been present, then only the Laplace transform is said to be exists. Okay. Similarly, in the next one problem as, if we reverse this particular one, that's e power minus t u of minus t plus e power minus 4t u of t, like this. This is also a two-sided signal only. This is also a two-sided signal. In the two-sided signal, this is the left side, this is the right side. Therefore, corresponding Laplace transform as 1 by s plus 1 with the RU of s will be less than minus 1 plus 1 by s plus 4 with the RU of s will be greater than minus 4. Right that. Therefore, when we plot that same ROC like this, minus 1 one particular line and minus 4 another line, RE of s greater than minus 4 like this, and the RE of s less than minus 4 like this. Therefore, the common intersection region is small, this particular small. That is, this particular one is a strip, ST or a strip bounded by the poles. Bounded by the poles. It will be the bounded by the poles. What are the poles bounded by? The poles at minus 1 comma minus 1 and minus 4. Minus 1 comma minus 4. The bounded by the poles. Minus 1 comma minus 4 like that. Okay. That is for a two-sided signal. The ROC is a strip. Bounded by the poles bounded by the poles. Here for example as minus 1 and minus 4 like this. This is the cases. Next one we'll see the problems related to some sine functions. Let that first one as sine square of 3t into u of t. Consider that x of t is equal to sine square of 3t into u of t. For that we need to find out the Laplace transform x of s. Simply that, like that. That's why I am writing that x of t as 1 minus cos of 60 as 2 into 3t, no, that is by the 60 by 2 into u of t. Therefore keep this 1 by 2 as outside. Therefore 1 minus cos of 60 into u of t. It's nothing but 1 by 2 into u of t minus cos of 60 u of t. Therefore, to take the Laplace transform of this one, that is x of t, Laplace transform of x of t is, keep that 1 by 2 outside. First the Laplace transform of u of t minus Laplace transform of cos of 60 u of t. Therefore 1 by 2 into Laplace transform of u of t as 1 by s minus s by s square plus 6 square. S by s square plus 6 square. That is your corresponding Laplace transform x of s. X of s. If you simplify that expression, we will get the Laplace transform simply. That's 1 by 2 into, what we'll get here is s square plus 6 square into s. Here s square plus 16 square plus s square. Sorry, minus s square. Then minus gets cancelled. 6 square is 36. 36 by 2 is 18. 18 s by s square plus 6 square. That is your answer, x of s. Okay. Similarly, the next problem with the x of t is equal to cos square of 2t into u of t. This will be written as 1 plus cos of 4t by 2 into u of t. Therefore 1 by 2 into u of t plus cos of 4t into u of t. that is x of t. Therefore, Laplace transform x of s is equal to 1 by 2 into Laplace transform of u of t, first one, plus Laplace transform of cos of 4t u of t. Therefore, when we write the Laplace transforms, it is 1 by s plus 1 by s into s square plus 4 square is 16. When we take the LCM, it is 1 by 2 into s into s square plus 16. Here also s square plus 16 plus s square. Therefore, 1 by 2 into 2s square plus 16. Take the 2 common and cancel it. Therefore, it is s square plus 8 by s into s square plus 16. Okay? That's it. That is your Laplace transform x of s. S square cos of cube of 2t u of t. U of t. Then simply write that one. X of t. Then its Laplace transform as x of s, left side. This 1 by 4 kept it outside. Therefore, Laplace transform of cos of 60 into u of t plus 3 into Laplace transform of cos of 2t into plus, I am writing it here, 3 into Laplace transform of cos of 2t into u of t. For the first one, it is 1 by 4 into, for this one it is s by s square plus 6 square, that is 6, plus 3 into s by s square plus 2 square means 4. That's it. It's the Laplace transforms. That is the expression for our Laplace transform x of s. Okay? Is it clear? For the sin square 3t, cos square 2t and the cos cube 2t, like that.